Okay, in this presentation we're going to look at an exploratory data analysis question. It's a short enough question, but it does come up in the paper as a question in its own right. So just to complete the paper properly, we will answer this question. I'm going to add in a few additional remarks. A sample data set X is comprised of the following 10 numbers there. So 10 numbers there, 0.582 all the way down to 0.6300. So the exercise is find the mean value of X, calculate the standard deviation of X, and find the median of X. So it's very short and sweet. So we're just going to set it up in R as follows, just to sort of save it as a data set there called X. That's it, really. Okay. And we get the mean of X, just mean of X, 0.566, standard deviation of X, 0.351, and the median of X, which is 0.606. Excellent. So I think that actually, weirdly enough, answers all of the questions, but let's do a few other things here while we're here, just to sort of, learn a bit more about R. So here's a couple of things we can do. We can sort R using the sort command, and we can reverse the order of X using the rev reverse command. So those are two useful commands that might help you get a better understanding of how to work with R. Okay, a few more. The summary command gives a numerical summary for a little data set like that. It has the minimum, the first quartile, the median, the mean, the third quartile Q3, and the maximum value. Okay, so it has essentially the quartile values from 0 to the 25th percentile, 50th percentile, 75th percentile, 100th percentile, which is the maximum, but also the mean in there when required. Okay, and it goes median to mean. That breaks the order, but it doesn't matter. Another interesting one actually is the Tukey's 5-number summary, which is the minimum, the lower hinge, the median, the upper hinge, and the maximum. This is slightly different. The lower hinge is essentially based on the interquartile range, but it is Q1 minus 1.5 times the interquartile range. Okay, so I think box plots would use this. A lot of sort of formulations for creating box plots would use this setup here, and essentially this is the representation for a, this helps create a box plot with Q3 and Q1 as well. So the maximum and the minimum, something you might be interested in doing is finding the location of the maximum and minimum. So which dot min of X and which dot max of X return the locations or the indices of the minimum value and the maximum value of X. And we have a look at that there shortly. Just remember those values, 2 and 9. So we're going to finish up with this, rank and order. So let's start with rank. So I'm going to set up a little data frame with 2 columns. X is the values as we created there previously, and rank is the ranking of them. So the numbers are 5, 1, 2, 3, 8, 7, 9, 4, 10, and 6. Now what this is from the lowest value to the highest value, it gives the ranking. So it's a ranking in terms of where the ranking is how close to the minimum. Okay, so it's a ranking from the bottom. So the minimum value there is 1, and we recall that it's in the second index. It has an index equals 2, which is to say the second location, 0.04981. So that's the minimum. The next lowest one is the one that's after it in location 3, 0.15620, and so on. And all the way up to 0.9688, which in row 9, which is the 10th value in terms of from the bottom, which means it's the maximum because there's 10 numbers there. Now, order is an interesting one, and people sort of get order and rank mixed up. Now, rank is a bit more intuitive. Order is really for back-end purposes. It's quite handy, but you really got to get the hang of order before using it in anger. So it returns the indices of the vector in sorted order. Okay, so look at 2 there. 2 is the lowest value. Okay, so it's where to find the lowest value. Okay, 3 is where to find the next lowest value. So that's essentially what it does there. So where the locations of the lowest values in order. So it's a sort of parallels rank in some respect, or it just actually gives an indication of how to interpret rank from the point of view of computer. All the way up to the 4 gives the next lowest value, which is the third lowest value, and so on. And all the way up to 9, which is the location of the maximum value. So again, 2 all the way up to 9. So the minimum value is in 2, which is which min, and the which max is number 9, which is at the top. So it's essentially a way of expanding out which min and which max, but mentally distinguish it from ranking because it's a different thing altogether. Okay. And finally, you can actually use order to sort data according to ranking as well. So it's a different way of sorting the data, particularly when you want to sort a different variable. Here we have y sorted by the order of x, or x sorted by the order of x. But suppose we want to have a different ordering, or use that ordering for a different variable. That's how we might sort of keep it as well. So it just actually order x can be used as a way of sorting other variables the way that x is sorted. That's really handy, okay? Particularly when you're making graphs. Okay, we'll leave it there.